grade students. Mr. Lawrence here, and I'm doing a couple little OAA review videos to help make sure you're primed and ready to go. Remember, 8th graders, if you do your best, the test will be no big deal. In fact, I've heard rumors to say that this test is easier than the 7th grade test. Now, you guys are just about high schoolers. You know, we're down, what, 38 days, 39 days, depending on which day you're watching this, from being full-time high school students. You guys are smart enough. It's time to give up the childish ways where you don't feel like doing it, so you put a question mark, or you give up and you write IDK. Come on, you're smart enough. Try something. Always, 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 always do your best. That's all we expect of you. If you do your best, everything else will be okay. If you do your best and aren't successful, you know what? I'm going to look at the mirror. I'm going to blame myself. If you do your best and you're not successful, then I'm going to look at myself. See what I'm doing wrong, what I need to improve on. But make sure that you're doing your best, because it's too easy to blame somebody else. All right, so this first video, we're going to go way back to the first quarter and review number systems. And remember that our number system started with the natural numbers, right? We usually used an N to represent the natural numbers. And those were the numbers that started 1, 2, 3, and they went on forever, right? Okay, and then we learned about the whole numbers. And the whole numbers are just like the natural numbers in every way, except they also include 0, right? 1, 2, 3, and they go on forever. No fractions, no decimals. Next came the integers, and those explain what happens when you borrow money from mom and dad. You owe them money. Yes, we get into the negatives, right? Still no fractions, no decimals. Okay. These go on forever in both directions, have no beginning, have no end. Unlike the naturals that start at 1, the whole start at 0, the integers do not begin. And then we finally introduce fractions and decimals, some of them, with the rational numbers. Okay, these include all the integers plus they include fractions, any fraction. Okay, they include decimals that repeat or decimals that terminate. Right? So any fraction is rational. Okay? If it's a decimal that ends, it's rational. If it's a decimal that repeats, it's rational. But then there's these strange numbers that mathematicians discovered much later. Those are called the irrational numbers, right? And those are the decimals that never end, never repeat. For example, pi. Remember, 3.14 is not pi. It's just an estimate of pi. Okay? 2.14, boom, 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 dot, dot, dot. Right? The square root of, say, 5. If it's not a perfect square, then it's an irrational number. There is no number times itself that gets you 5. So there's some example of irrationals. And then all together, these all make up what we call the real numbers. Right? The real numbers. Okay, why do they call them real? There is a group called the imaginary numbers you won't deal with in this class. Okay, so let's check this out. To what number systems do the following numbers belong? Well, I have a nice little 5 here. See my little 5? Well, let's check our Venn diagram. By the way, if you wrote this down like 5 or 6 times, this Venn diagram, you'd probably remember it and therefore be able to write it on the OAA. You can't write it ahead of time, but once you get your test booklet and they say, go ahead and start, you can find some area of the test booklet and make the Venn diagram because it's coming from your memory, so it's showing you what you know, and then you can use the diagram. All right, well, 5, I'm just going to start on the inside here. Is 5 natural? It sure is. So 5 is natural. So I'm going to put an N there. Okay, now if I'm inside the natural circle, let me see here, let me put a 5 right inside this natural circle. There he is. Isn't he in the W oval and the Z oval and the Q oval? He sure is. So that means he's also a whole number, an integer, and a rational number. Now he's not irrational for 2 reasons. One, he's not inside. Okay, some of you are going to go, there's a 5 there. No, that's the square root of 5, not the same thing. So he's not inside this red oval over here, And 2, it can't be rational and irrational at the same time. It doesn't make any sense. Now, every number we talk about in our class, well, maybe not every number we talk about, but every number you're expected to know is a real number. Okay, so let's go up and check -5. Let me get a -5 here ready to go. I'll make them purple. Okay, and let me see, does -5 belong in the natural numbers? No, he does not. I think they just separated on me. Yes, they did. Why did they do that? Sorry, give me 1 second here, and I will group them back together. Okay, is -5 a whole number? No, the smallest whole number is 0. Is -5 an integer? You bet your bananas. All right, so it's an integer, which the symbol is z, right? And if it's an integer, it must be in the rational circle, and that makes it a real number too. Okay, 3/4. Where did fractions first show up? Well, they first showed up in the rational numbers. 3/4 must be rational. Can't be irrational if it's rational. Remember, ir means not. And then it's also real. -1/2. This is one a lot of kids make a mistake on. They want to put it in the integers because it's negative. But remember, the integers don't include any fractions or decimals. So yes, the answer to this one is the same as the previous one. Okay. Now, 3.21 ... That is a decimal that goes forever without repeating. Well, that's the definition of irrational. Irrational numbers are real numbers. Okay. Here we have 6.25, and the 5 has a bar over it, meaning that the 5 repeats. All repeating decimals can be written as fractions. That makes them rational. If it's rational, it has to be real. Okay, now, square root of 16. Do you know the square root of 16? Hopefully my algebra students will tell you that the square root of 16 is equal to plus or minus 4. They'll stop just saying 4. So, let's see here. 4. Let's consider 4. Well, that's a natural number, isn't it? Sure is. And if it's natural, has to be a whole, has to be an integer, has to be rational, and of course has to be real. And there you go. Okay, now the square root of 17. Do you know the square root of 17? I'll bet you don't. I'll bet you can guesstimate it. I'll bet you can tell me it's a little bit more than 4, maybe about 4 1/10. Okay, but that's not what it is exactly. Since it doesn't have an exact square root, it is irrational. It is a decimal that goes on forever without repeating. Okay, now we're going to talk briefly here about exponents, just to review. I don't know if you know this, but my algebra students should, that 5 to the 0 power is equal to 1. Any number, any non-zero number to the 0 power is 1. So -7, 0 power, 1. Yep. And notice I use the parentheses there because my calculator might misunderstand what I'm trying to tell it. 1 million to the power of 0. 1. Too easy. Okay, now a negative exponent. A negative exponent needs to use the reciprocal. So 5 to the -1st is the same as 1 over 5 to the 1st, which is just 1 over 5. That would mean that 2 to the -3rd is the same as 1 over 2 to the 3rd, or 1 over 8. Remember, 2 to the 3rd is not 6 because 2 to the 3rd means 2 times 2 times 2. It's not 2 times 3 because we wouldn't write it that way. We know how to write 2 times 3. We could write it like this. We could write it like that. Okay? So that's 2 times 3. This means there are 3 2's being multiplied. 1, 2, 3. Okay. 4 to the -2nd, that would be the same as 1 over 4 to the 2nd, and that would be 1 over 16. Okay, let's try these last two, and then we'll call the video a wrap. So 2 to the -1st is 1 over 2 to the 1st, or 1/2. 2 to the 0 is 1. 2 to the 1st is 2. Well, 2 plus 1 is 3, plus 1/2, 3 and 1/2. There we go. All right, 5 squared plus 5 cubed. Well, we have to evaluate. 5 squared is 25. 5 cubed is 125. So if I add those together, I get 150. It is not possible to write this as a base of 5 to some power, at least not using integers, because they have different exponents. Okay? If the bases were the same, I might have just been able to add together. I'm sorry, if the exponents were the same and the bases were the same, I might have been able to do some kind of addition trick. But I'm going to just simplify, evaluate, and then set it equal. Okay, that was your review video for today. Got a couple practice problems for you. Go ahead and work on them. Mr. Lawrence signing off. Good night, everybody.